Might have been my marker too. Okay, so in this, we're really going to get into Lewis structures today. So, we're going to start, right? What was the only person saw it, wasn't it?
Power's down out.
It's all good. I'm going to start, and I'm going to show you the belly of the beast, okay? I'm going to show you the worst of how bad this can get. Really, really hard one. Give you the rules breakdown, and then we'll go back to super easy and work our way up to it, okay? So you get an idea of where we're heading. So in this, let me introduce you to my friend. My friend's name is carbonate, a CO3, 2 negative. As we're taking this moment today, let me foreshadow what this is. Carbonate, CO3, 2 negative, is something that we like to call a polyatomic ion. You will be getting a list of polyatomic ions that you must memorize. You must memorize their name and their chemical formulas, because we're going to use them in nomenclature. Just a little foreshadow.
Spencer Kenny and Zion Lusk, please report to the gymnasium.
I was about to say, just tell them you were not around them, you were not there.
Alright, I will.
Okay, first and foremost, step number 1, find your center atom. You will do this by comparing the electronegativity of the atoms within the molecule or the compound. The one with the lowest electronegativity is the center. So in this case, we have carbon and we have oxygen. So whenever you look at it, and you go to the periodic table that I gave you maybe 10 of by now, you look at it, carbon has an electronegativity of 2.5, and oxygen has an electronegativity of 3.5. Which one is the lowest? So carbon is the center. Now in this we need to add an important note. Hydrogen will never be the center. Just because it's first period, it's bright and early, and I know your brains are fresh, you're awake, you're energized, you've had a big cup of coffee, you're ready to go. Why would hydrogen never be the center?
Because it's not special.
Well, that was very neat. Wow. I'm sorry, hydrogen. I think you're special. Just kidding. Detail as to why. Why is hydrogen not special? Something very, very special. It's very fresh in your mind. It's very fresh in your notes.
Is it atomic?
No.
Noble gas?
No.
It's number 1.
No.
It has a small atomic weight.
No.
It has the wrong chemical symbol.
No. Stop guessing.
I give up.
Someone look back at your notes on the rule breakers.
Oh. It will feel the first subshell. Hens have 2 electrons, hence only a single bond.
So it only makes a single bond. So hydrogen can only bond to one thing. So it can never be the center because it will only bond with one. So you draw your center atom. I'm going to come over here because I may end up having to have more space. I'm writing pretty big today. So carbon's our center. Then you draw the other atoms around it and place a single bond between them. So I have oxygen, oxygen, oxygen. Single bond, single bond, single bond. This is a very good opportunity to show you that this little stick thing is a bond. And this is 2 electrons being shared between 2 atoms. So now that we do that, we just did step 2, which I like to call draw the skeleton. Then we go to step 3. Give everything. A full octet. Got a shirt. Woo! Alright, so in this, we're going to give everything a full octet. So what I'm saying is this. Every atom in this molecule, we're going to draw a full octet. This is where I apologize. I should have already stressed this to you. This is not the lesson to use a pen on. You're definitely going to want to use a pencil. That is my apologies. I should have warned you. Because you're going to need to erase some stuff. So everything has to have a full octet. Here's the thing. If there's a bond, that counts as 2 electrons for it. So in this case, this oxygen has 2 electrons. I'm trying to give it a full octet. So we need something we call a lone pair, and we figure out how many lone pairs we need. We need 6 electrons because there's 2. Okay, so 8 minus 2 gives me 6. I need 6 electrons or 3 lone pairs. So here's 1, 2, 3, 4, 5, 6. That oxygen has a full octet. Same thing down here. This oxygen is the exact same. So it's 1, 2, 3, 4, 5, 6. Same thing on this oxygen. 1, 2, 3, 4, 5, 6. Then in this, we look at carbon. How many electrons are being shown on carbon right now? Very good. There you go. 6. So how many electrons does carbon need? 2. 2. So just one single lone pair. So there's 1, 2. There's the lone pair. Bada boom, bada boom. Now that you've given everything a full octet, comes the fun part. Calculate the number of electrons you must represent. Alright, so in this is the thing. When I'm saying the electrons, I'm talking strictly about valence electrons. That's what this is. Just straight up valence electrons. So whenever we're counting this up, we're calculating this, we're going to get that number from all of these. So let's count up. I write down my elements. I write down how many of that element I have. So I have 1 carbon, 3 oxygen. I multiply it by the number of valence electrons for that atom. Where do we find that information? Off your handy dandy periodic table. You will refer to it. So the perfect example here is carbon has how many valence electrons? 4. Goodness, I'm so proud right now. So I thought we was going to struggle with that. So 1 times 4 is? 4. And y'all thought y'all weren't going to do math in this class. How many valence electrons for oxygen? A 6. What's 3 times 6? Ooh, look at you. What's 18 plus 4? Yeah, come on now. So there's 22 electrons here. There's a special thing we have to do here though. On step 4, you will add / subtract the overall charge as well. What I'm saying when I'm saying this is, in this, your polyatomic ions, they come with overall charges. That overall charge, this is where we take care of it. This is the most simplistic, easy way for us to take care of it and handle it to where it's not a problem for us, so that we don't have to worry about it later on. So you need to think, what charge does an electron have? So electrons are negatively charged. I have a -2 charge on carbonate. This right here is what I'm talking about. That 2 negative, that -2 tells me there's 2 extra electrons. If there was a positive charge, that means I've lost an electron. So if you see a negative sign up there on your molecule, it means you need to add electrons. If you see a positive, that means subtract electrons. I know it's opposite of what you think, but you have to have it in your mind that you're dealing with the electron, which is negatively charged. So in this case, we will add 2 electrons to give us, what is 22 electrons plus 2 electrons?
24.
Electrons. See? Yes, 24. So 24 electrons. Yeah, I need the space. Good thing I moved over. So we have 24 electrons that we have to represent. I'm going to take the space for step number 5. All right, step number 5. This is where everything becomes fun and interesting.
Mr. Thomas or Mr. Adams, call the office.
So in this, on number 5, this is what we're looking at, is you're going to take and count the number of electrons shown.
This announcement is for freshmen and sophomores. The PSAT
that was canceled due to flooding is rescheduled for a week from today on February the 23rd. We'll be putting out a post regarding that, but all freshmen and sophomores need to try to be here next Tuesday, a week from today, for PSAT testing.
Are you still testing? Yes.
But it doesn't matter, you wouldn't be down here in the room anyway.
That's right, I'm not coming.
You get me choked up. Count the number of electrons shown. Better do this in purple. You must show only the number of electrons you have, no more / no less. I'm going to show you how I count these. Follow a pattern. If you need to, it's okay to write the numbers over the electrons to make sure you don't get mixed up. Here's the thing to keep in mind. These bonds, they all represent 2 electrons, and they must also be counted. You have to count those bonds as well. So this is what I do. I start at one point and I work my way around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I'm showing 26. This is where the belly of the beast comes in. You must show only the number of electrons you have, no more, no less. I'm going to try it with this marker because it looks better. Watch it today and let me know if it's still a problem. If showing too many, use double / triple bonds to fix it. I'm literally just trying to put this in very simplistic terms. In this, there's such thing as a double and a triple bond. So these are single bonds. But what you'll see is things have double and triple bonds in it. Now the important thing of it is to try and keep symmetry in the molecule as much as possible. So in this, we need to fix this. I'm showing too many, the number 2, too many electrons. So I'm going to add a double bond. The key to this is you have to add it to something that can have it added to it. So oxygen and carbon, those are fair game. They can have it added to it. What I'm saying there is, like, if I had a hydrogen here, could I add a double bond? No, because hydrogen only forms a single bond. That's it. No more. But I can add a double bond in here. So there's the double bond. Now the reason we do this is to fix the number of electrons. anytime you add a double bond, you best check your octet. So I just added this bond here. Look what happened. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 electrons shown on that oxygen now. Can oxygen break the octet rule?
No.
No. So what you do is you take a lone pair off. So we remove that lone pair. Here's the other thing though, and this is what I try to tell students to help them with this. Whatever you've drawn the bond between, you need to double check both of them. So we fix the oxygen. We're only showing 8 now, right? 1, 2, 3, 4, 5, 6, 7, 8. So now we're only showing 8 on the oxygen, but look at the carbon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Teachers, pardon the interruption. I do want to remind you about the protocol for a sick student. Please do not send them up here on their own unescorted. And that doesn't mean you send them with another student. Please just have them step outside of your classroom, call the office, and one of us will come down and get them so that we can escort them up here. Hallie Franklin to the office, please. Thank you.
All right. So in this, we got 10 electrons shown on this carbon. How do you fix it?
Get rid of lone.
Get rid of the lone pair, these 2 electrons up here. Now, this is where you can go in and check your octet rule on everything. So 1, 2, 3, 4, 5, 6, 7, 8. And oxygen's good. It's carbon. 1, 2, 3, 4, 5, 6, 7, 8. Carbon's good. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen's good. 1, 2, 3, 4, 5, 6, 7, 8. That oxygen's good. Everybody has a full octet. Now, you put the double bond in, recount, and make sure you're only showing how many electrons?
24.
24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Woo! Took us a while to get here. You're not done. Your last and final step. Rule 6. Show charge and resonance. Structures when needed. All right, to talk about the charge first, we'll deal with it first. So when you're dealing with a charge, this is what you're looking at. I know there's a charge in this molecule. The reason I know there's a charge in this molecule is I look up there at the top and it shows a charge. It's a dead giveaway. But it is always crucially important to check your charges. I have been known in the past, hint, hint, to give a molecule that has charges within them, but does not have a charge overall. So the charges within the molecule cancel themselves out. So in this is what we do. It's like an operation. So in this case, everything has a full octet now. You're not worried about that part. You only do this when you're checking charge. I cannot stress this enough. You will only do this when you want to check the charge. I cannot stress this enough. You can do this physically if you need to. But as soon as I do this, what I'm about to show you on this molecule, it no longer can be my correct answer that I give Mr. Hall. You cut the bonds in half. I say do it mentally. So we're going to cut, cut, and cut. Remember, you only do this when you're checking charge. Whenever you cut the bonds like that, it's like you cut it in half and you send one electron to the left, one electron to the right. So this bond has one electron there, this bond's one electron there. But I have the other side. One electron here, one electron there. Everybody good? Same thing down here, up here, over here, and over here. Everybody okay? Now whenever you're checking charge, this is what you're going to do. You will subtract the number of electrons being shown from the valence electrons that element started with. So what you're going to do is you're going to look on your periodic table.
You don't want to use this one. It's funky color.
I'll use this one.
Well, it's probably the same color.
Dang, hey.
All right, thank you.
So you're going to look at your periodic table and you're going to look. Okay, so let's start with carbon. Carbon's simple enough. How many valence electrons does carbon normally have? And that's on the periodic table. We're not worried about right here. We find the number that they start with. How many valence electrons? 4. Carbon starts with 4 valence electrons. Subtract from it how many valence electrons you're showing now. This is why you do the cut. 1, 2, 3, 4. 4 minus 4 is 0. Carbon does not have a charge. It's neutral. So let's jump over to this oxygen over here. How many valence electrons does oxygen normally have? 6. Minus how many valence electrons are we showing on this oxygen right here? 6. 1, 2, 3, 4, 5, 6. This oxygen is neutral. So let's jump down here to this oxygen. Oxygen starts with 6 valence electrons. How many valence electrons are we showing now?
7.
7. 6 minus 7, -1. This oxygen has a charge. So now you have to represent the charge. I'm going to erase this. And you literally just put the charge out from it. So right next to it, that's how I like to do it. So I show the negative charge there. About this oxygen over here, oxygen starts with 6. How many is it showing?
7.
7. So -1. So we got to show a charge here, so I would just stick my charge right there. So now I've shown my negatives. I've shown you how to get your charge. Now I want to talk about resonance structures. I know this is not going to seem like a big deal on this level. This is a very simplistic, like really easy, broke down chemistry in the grand scheme of chemistry. Resonance structures are so important. I don't have time today, but I will tell you about thalidomide. I don't see you guys tomorrow, Thursday. Okay? Thalidomide was a medicine that they thought was really going to cure some major problems, but it actually ended up causing a bunch of major problems because of resonance structures. So here's the thing, when resonance structures apply, this double bond I put here, could I have put it anywhere else?
Yeah.
Yeah, I could have put it here. I could have put it here. So guess what you have to do? You have to show all these molecules in every place that double or triple bond can go. So what I'm saying is you got to start here. And this is why I'm saying don't do this cutting and stuff, because now I can't use this. I have to redraw it. So I have an oxygen, double bond, carbon, single bond. I have a negative charge there and a negative charge there. So that's the molecule right here. I literally just copied and pasted it without all the nasty junk. So now, to show resonance, we got an equal sign with two arrows on the ends. So let's put this double bond on the bottom. You still have to show the charge, but now the double bond's down here, so now the charge is moved. Don't make this harder on yourself than it needs to be. You literally, wherever the double bond is, there isn't a charge on the oxygen. You figured that out. I'm going to take this resonance structure up because if it's over to the right, it's not going to be on the camera. And this right here is the proper Lewis structure for carbonate. Any questions? How y'all feel?
Weird, I feel hopeful.
All right. This is a hard one. That was a hard one. When I see you on Thursday, we're going to start easy and we're going to build our way up. Remember, Friday, you have your element quiz. Please, 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 please study. All right?